All right, so, just as a reminder, like, I don't know, I feel like we never talk about the book. There's a beautiful book over there, it's green. I do stuff out of the book, it's just, I use the book as my guide for notes, and then I kind of do my own notes for you, but if you ever need extra resources, the book is there, and that's where I'm getting my information from. I just hate you guys reading a book. So today we're gonna be solving polynomial equations, which is exciting as can be. So we've done a lot of solving quadratics, and a quadratic is a polynomial, so we're just gonna kind of add to that. So the directions are just gonna say find the real or imaginary, so that's kind of a throwback, good old imaginary numbers, solutions. All right, so here's now numero uno. And just as a hint, when I say you're solving a polynomial equation, you're going to be factoring, so. Factor. It's really just a factoring problem. It's just making sure we have all those cases organized and we remember them and all that fun stuff. So the first one, just a reminder, when we do say we're factoring something, we want it to be equal to 0. So I will rearrange this. And then just as another heads up, if you're ever rearranging a polynomial, please just make sure it is written in standard form. So standard form is from highest exponent to lowest. So that's important when you're factoring. So I look at this and I say, okay, if I need a factor, please always be on the lookout for good old GCF. Hi.
I'm so sorry. Can I have 1 minute?
Oh, yeah.
Excuse
me.
So
no, it's fine.
She was asking me to cut, what to cut out.
Okay, so we did.
So should we keep?
We did, yeah. The quadratics is like one of the most important
Definitely.
things.
So let me see. I'm completing this square.
Yeah, you need completing the square. You need quadratic formula. That's we did transformations. We need square roots. Okay, keep going.
Modeling with quadratics.
Yeah, I mean, we did do that, but you can decide if there's something different.
Because she needs us to cut. So right now it's 115 hours.
Oh yeah, no, that's.
We need to get it down to about 50 hours.
Oh, okay. Okay, so you need to cut a lot. Okay.
So we need to cut a lot. So maybe cut that out.
Yeah, that's fine.
And then.
If you guys can't get it down, if you keep it at 70, what I can do is just take out of their other courses.
There you go.
Oh,
We could get it to 70.
We don't want to kill them here.
So systems.
So we did systems.
Let's see if there's anything specific.
So graphically, elimination, substitution, 3x3s. Linear programming, cut out.
Oh, good.
Mixed degree system, cut that out. We've done that in the past, but we didn't do this.
Definitely cut
out.
performance tasks, but keep unit tasks.
Yes,
okay. Polynomials.
Subtract, multiply. So yeah, we're doing this right now. Division, binomial theorem.
You're only at the beginning of the semester too in this.
That's great. I know.
This is what they're learning in the beginning.
Yeah.
We haven't even got to the bottom part of it.
Well,
no, the bottom part we don't do a lot.
Maybe we can cut a lot.
So yeah, we can cut a lot from the other side.
Okay. Sorry.
Compositions episode.
No, they're fine.
Thank you.
They'll live.
I'm sorry, guys.
Take more time.
I was like, yeah.
You're the cutest ever.
Composition of polynomials.
Let's just cut
Just
it.
cut it.
Yeah. Polynomial theorem, yes. Simplifying polynomial expressions, yes.
What's in the polynomial functions? Because then a lot of the other stuff, I think, actually, just go to the end tomorrow.
Oh, like
a lot of the stuff we don't do. Math modeling, we don't do.
Okay.
Let's take the whole thing off.
Yeah.
Like we do piecewise.
Just break it
Absolute
down.
value functions, absolute value inequalities, piecewise.
Yeah, and then everything else we know.
Oh, come back.
And I keep getting that.
So we want to take this out.
Yeah, that.
This out.
We do transformation.
Yeah.
We do
And
compositions.
Compositions.
Take out the modeling. And take
Yeah.
out
And
the
any
performance
performance task.
I already took the performance out.
Okay.
Yeah.
Yeah, it's fine, whatever. That's
Yeah,
fine.
just to give the kids.
Just
a break.
there, okay. And then trig functions we're doing those next. So we probably do all of
Either
that.
9:30 or 10.
unit,
And I'm
circle,
gonna
rectangle.
be honest, I don't really know if we're gonna do all of that because
Graphing, sign, and
we didn't do it
cosine.
last year, and this is the first year we're gonna do it. No, we won't do graphic. Take graphing.
So take this out, take this out, modeling,
Just take it out. Okay.
beautiful,
Stats and probability, we don't do any of that.
good.
We don't do, we don't do logarithmic. We do that in pre-calc now.
Okay, good.
I don't think
So-
we did any extra.
Everywhere, vacuum the dining room. And then just make sure everything's organized.
That would be
We might
great.
do it later, but just take it out.
I mean,
It won't
do
hurt,
they need
though.
it for their
No,
future
'cause-
career?
Because you do,
No.
because you're gonna redo
You're
it
gonna
in
redo
pre-calc.
it in pre-calc, so no.
Radical
Radical
functions.
functions.
I know.
I haven't done the functions. That might be something we do after undergrad.
Ooh, rational
Okay,
exponents.
good at middle school, what it looks like.
That was for K through 8.
I think it is. Okay. They did.
Because I got homework with my phone, I
Okay.
looked it up immediately. And it's like K through 8, so they could come back to school full time and then they'll have it when they're back.
You can't do both at the same time.
Exactly.
I have a class with computer.
I
I don't think
mean,
anyone really knows what it's like.
I still think they're gonna postpone it.
Well, you want to hand one because I'm not very good
I
at
don't know.
straight. And then she's good at that.
maybe keep it, because that's all good stuff we
Yeah, I
should
know, I'm like,
know.
they should know it, and we probably will do it, it's just I don't know.
The issue, how you study.
Solving equations containing two radicals, I don't know if that's
No, you don't.
necessary.
Just give them the basics.
Yeah.
Thank you.
Rational
rationals we did too.
I'm
functions.
happy to.
Oh, we didn't do vertical asymptotes,
What?
so take that out.
Okay,
Really?
Just take out graphing rationals.
great.
Already?
We have inequalities, and take out modeling.
Okay,
Are they
good.
updated? Huh? Are they updated?
Modeling. Ooh, should I keep modeling
That's in
systems? Yeah,
Yeah, that's fine, we do work on
yeah,
systems.
okay.
But in the, other one, what was it?
Gosh darn it, there was rationals, got it. So take out rational inequalities.
Yeah.
Take that out,
Take out
take
modeling.
this out.
All right, what do we have for time right now?
69 or 70 hours.
So,
Okay, I'll just take out the other.
or, yeah, just go through.
I'll just go and pick
If
stuff.
we- Yeah, if there's like little things.
Was that all right, Amanda?
All right, sorry.
Tricia, thank you.
Oh, no problem, anytime, anytime. I could have just told you guys to solve this one, come on. All right, so sorry, me too, Marcia. There is a GCF there, so please take that out. And then that's going to give you a nice little quadratic, that you can now factor. So as we factor this, you just go through your normal steps. What are my factors split up? 2x and x. That would be 3 and a 1, right? Because I would need that negative, that positive to make a -5. And then from here, we solve it. So we basically just set each factor equal to 0. These are all nice linear ones. So don't forget about that x, that equals 0. That's my first solution. We would have 2x plus 1 equals 0, so x would be -1/2. And then we would have x minus 3 equals 0. We're kind of used to doing that step now anyways. And we would get our 3 beautiful answers. And then just as a reminder, and I'll keep pointing this out as we go on, since this is a cubic, a degree of 3, there should be 3 answers. So whatever your degree is how many solutions you should have. So just as a heads up. All right, so that's just going back to like basic factoring, but just pay attention to the GCF stuff. That stuff kind of pops up all the time here. Oh, next one I want to show you. Yep,
Did you set that up right?
I believe so.
Okay.
Be careful with the 5 and the 6. Did you have this?
Yeah.
The reason you can't do that is because to make a -5, these would both have to be negative. But when you have 2 negatives, that would make a +3 there. If you distributed it back out, it would be 2x squared, and then that would give you -5x.
Oh.
But when you distributed that, it would give you a +3, and that's a -3.
Oh, yeah.
That's always the one that people get confused on. It's just that one sign will mess you up. So be careful. All right, numero dos.
What are the 3 answers for that?
Oh, I'm sorry, 0,
And x equals 0, x equals.
-1/2, and 3.
Okay.
I'm
I
sorry.
wrote everything else down. I was just trying to.
They threw me out because they come in and interrupt me.
Sorry.
It was fine. It's all gonna be fine. Just as a class is always so short anyways.
Mhm.
Okay, So 2 is kind of the same idea. We're gonna set it equal to 0, so I'll do that first. We are going to factor it, so we might see different exponents here, but it's still factorable. Just a reminder of things like if I have x to the 4th, when I factor that, I split it up and divide it up. That would be x squared and x squared. So just making sure that you do split up that exponent evenly. And then what am I going to have for numbers? I'm going to have 4 and 1, because if I have -4 plus 1, that gives me -3. Okay, so I'm feeling pretty good, it's factored, but we're not done, because now this gives us 2 quadratics. So you're saying, oh man, we got to keep going. The nice thing is this is a difference of 2 squares. X squared minus 4 would factor to x plus 2, x minus 2. So I can pretty easily find the solutions to these. I'm not even going to set it up. If we set them equal to 0, that would give me -2. That would give me +2. And the issue with that other binomial there is that's not factorable, unfortunately. X squared plus 1 is not a difference of 2 squared. There's a sum there. So if factoring is not an option, if something is not factorable, use a different method, because we know how to solve quadratics. I'm going to solve this using square roots. So you have square roots, completing the square, quadratic formula. You have all sorts of options. But square roots looks like it's going to be easiest for this one. That gives me -1. And then when I take the square root, hey, who remembers what's the square root of -1?
I.
It's I. And remember, when I take the square root, it's plus and minus I. So I wrote them both as 2 separate ones. But if you wrote plus or minus I, that's perfectly fine. Excuse me. So that gives us 4 solutions. So what I want to do now is I want to show you, like, what does that look like on a graph? Because we've been doing graphs and we've been talking about zeros, which is basically what we're finding, right? But what happens when one of the zeros is imaginary? Like, what does it look like? So I want to show that to you quickly. And then we just have a few more other quick factoring ones. But once again, factoring is always your first step. And then once it's factored, you might have to do some other fun stuff to actually solve it. So you're going to see in the next one, we'll do a little quadratic formula. We'll go from there. All right, let me just throw this graph up for you. And once again, with this imaginary stuff, you would never have to graph it by hand. It's one of those, like, you kind of need a good old Desmos or some sort of technology to do it for you. But I just want to kind of show you what it looks like. Sorry, just going to set up my other computer so the people here can see it too. All right. Desmos.com. What's happening? Go away. Oh, no, okay. All right, so I'm going to put in that exact equation we just solved. I'm going to go my graphing calculator. Once again, you have this technology, use it. Like Desmos is kind of my best friend because it does a lot of the work I need to do for me, I'm going to be honest. -4. Okay. So let me just move this down a little bit, just so you can kind of see. So we know a lot of things about that equation to start, or what the graph looked like. When I look at the original equation, there's an even degree, and the leading coefficient is positive, so we knew it was going to be up. When we solved for the solutions, we found -2 and 2 were 2 of the solutions, so that was pretty good. So we know that those were 2 of the zeros. But then the other zeros were I and -I, and it's like, what does that even mean? Basically, all that affects is how many turning points you're going to have. Because if you think about it, if this was x squared, it would be a u. But to be x to the 4th is going to look different. So that's where, these turning points come in, and that's what the imaginary parts do. So you would not have to do this by hand, just as a heads up. This is something you would use technology for, or you could plug points in, but I wouldn't do anything too crazy to you. But just so you see how imaginary solutions affect the graph, it really just affects how many turning points. So when you see all these little like turns here and there, that just means you do have imaginary solutions. You can't see them on your axis because they're imaginary, but you can see them just in the way things are kind of moving. So just as a heads up, it's nice to kind of relate what we've been doing to graphing to this, because like, what do I do with imaginary? You look at technology, basically. You wouldn't have to do it by hand, so just as a heads up. But it's nice to kind of see that. So I just wanted to show you that in case you had a question, like, how the heck would I do that? You would use Desmos, that's how you would do it. Make your life easier, right? All right, so I just wanted to quickly show you that, just to relate it to what we were doing recently. So we see the real parts on the axis as the zeros. And the imaginary parts kind of just affect the shape of the graph and how many turning points there are. So just as a heads up. All right. Let me see number 3. Oh, number 3 is just a good reminder. It's been a while. This is a difference of 2 cubes. Oh yeah, it's up. Yep, thank you. I know, I didn't turn it back. I did the same thing last period. One of these days I'll learn, just to always check. Thank you. Okay, so difference or sum of cubes. Let's just remind ourselves what we're doing. When we factor this, we start with a binomial, and then we'll also have a trinomial, just as the general setup. We're going to take the cube root of the first term. The cube root of x cubed is x. And we're going to take the cube root of the second term, and that's 10. Because 10 times 10 is 100 times 10 is that. So this is really, like, those are the 2 things you really need. So then the rest is kind of based off this. The signs, we use the word SOAP. So it meant same, opposite, always positive. So this first sign is the same. Okay, so that's going to be minus. So then to get the trinomial, we square the first term here, x squared. And then for our sign, we do opposite, which is plus. We multiply these 2 terms together. That gives me 10x. And then we add always positive, and we would square the second term, which would be 100. So it's been a while. Maybe some of that was just like a little rusty. You couldn't remember a specific thing. But we actually have to solve it. I always like the linear factors because this is quick to solve. My first answer is x equals 10. And then we have this other piece here. It's a quadratic. Unfortunately, it's not factorable. So I'm going to use the quadratic formula to find the answer to that bad boy. So what am I going to get? Negative 10 plus or minus. Underneath my square root, if I could talk, you would find the discriminant. It is negative 300. So I know I'm going to have some imaginary answers because of that negative over 2a. I got a little bit of simplifying. The square root of negative 300, that's divisible by 100, and I need an I. So that would be 10I root 3 over 2. So remember the I takes care of the negative. I'm kind of just breaking down 300. And then I can reduce that, because everything's divisible by 2, to get negative 5 plus or minus 5I root 3. So let's just kind of take a second, 1, to just get caught up. But 2, just to kind of think what's happening. So we had a difference of 2 cubes. This is cubic, which means I should have 3 solutions, which I do. I have 1 here. And if we're thinking about the graph, this is where it would hit or this would be one of the zeros, right? It's real, so we'll just go through that point. And then I have 2 solutions here, right? Because the plus minus represents 2 instead of us having to write it twice. But those are imaginary. So we wouldn't necessarily see it on the graph, but maybe it would have an effect on the shape or what's happening. And we'll go from there. So once again, cubic, 3 answers. If I were to graph it, this is the only one I would actually see as the 0. The imaginary would just have an effect on the shape. Any problems with that one? Okay. I'm actually just going to do
One more.
Yeah, I'll just do one more. Because actually 4 and 5 are very similar, so I'll do the harder one. Even though it's really not. It's more to remind you of how to factor by grouping. Because once again, it's been a while. All right, so we've seen trinomials, binomials, all sorts of nomials out there. This one is a polynomial with 4 terms, and we do need to know how to factor it. And we do something called factor by grouping. So when you have 4 terms, you're going to start by making 2 groups. First 2, the second 2. From these 2 groups, you're going to take out the GCF. So in this first group, the only thing they have in common would be x cubed. And when I divide that out, I'd be left with x squared minus 9. Okay, so I'm just gonna kind of keep trucking along and see what happens. I'm gonna do the same thing for the second group. Just as a reminder, I don't even know, it's been a while. These are both divisible by 27, which is fabulous. What I do want to happen is when I divide that out, I want this to match whatever kind of comes over here. I do need their signs to be the same. So since this is positive and negative, I need to make that positive negative. So I'm going to make that a negative 27 just to change my signs. And I'd be left with x squared minus 9. That should always happen with grouping, that these are the same. So that's kind of a good hint that you're on the right track. And then this one's going to be fun. To write the answer, the factored answer, you would take these 2 outside terms, those 2 GCFs that you found, and you're going to put them together in a binomial. And then whatever repeated here, you just have to write once. Now we're not done. That would be too easy. We still need to solve both of those. We have a cubic, we have a quadratic. Looks like fun. Let's start with a cubic. X cubed minus 27. Do I set that equal to 0? You still see me. That is a difference of 2 cubes. Oh my gosh, it's almost like I planned that we kind of did review problems more than once. So I would get x minus 3, and then x squared plus 3x plus 9. Okay, so I find the first solution is just x equals 3. Okay, feeling good.
We have to do all of that.
Oh yeah, you got. I know. That's why
So it's
I
like-
picked the
this is
doozy one for the last one,
This
guys.
is like the other one.
Then I need to find 2 answers from this because it's a quadratic. So I'm going to use quadratic formula. Negative b plus or minus the square root. I forget what it came
Can you
up.
just plus 27 and then take the cube root? And then plus.
No, you can't. It's illegal. Sorry, can't do it. I know, that would be too easy.
Who makes up the rules?
I don't know, not me. I can tell you that much. But yeah, you can't do that because if you did that, it would only give you an answer and you need 3 answers and it's just like a big old pain in the butt, sorry. B squared minus 4 times A times C is going to give me negative 27 all over 2A. So what's that, 9 and 3 and I and 3I root 3 over 2? Okay. I can't do anything else to that. All right. So we factored. We took the cubic, we solved it. So we should have 3 answers, right? So if it's a degree of 3, 3 answers. We have a 3, and then the plus minus represents the other 2. Whew, okay, that side's done. This side.
Oh my god, we need 5 answers because of
Yes. Oh yeah. Look at that just clicked. Yeah. We do need 5 answers. You are correct. This one's easier because x squared minus 9 equals 0. You can use square roots, or you can just say this is a difference of 2 squares. And x will equal negative 3, and then x will equal positive 3. Okay, what a delight. We got 3 answers, or 5 answers. Now, there is one thing I wanted to point out to you, and someone had asked this in my other class, and I was actually planning on bringing it up anyway, so that's delightful. Hey, remember from like yesterday? And if we had zeros and there was more than one of the same 0, we would write a multiplicity. Everyone remember that? Okay, it was like 24 hours ago. Like 3 multiplicity 2 means there's 3 zeros. So the question was, hey, I have an x equals 3 here, and I have an x equals 3 here. How do I write that as an answer? So the answer is don't write multiplicity, okay? I know it's confusing. You only write multiplicity when you're talking about zeros on a graph, okay? It does not ask about the zeros on the graph, it just says find the solution. The only reason I care about multiplicity is because it just affects how it goes through the point, right? It either bounces or it goes through or it flattens or whatever. So if you're just solving and there's no graphs in sight, don't say multiplicity at all. Technically, I don't even actually have to write that answer twice, I only have to write it once.
But then there would be 5, and you need to show the 5.
That's true, but I mean, it technically is.
I don't like this anymore.
I know. But just as a heads up, you only do multiplicity when you're referring to a graph, so just as a heads up there. You don't need to write it in this case. Technically, you don't even have to write it twice, but go ahead, whatever. Oh, sorry. All right, we're actually fine, because we still have 10 minutes till dismissal, and then technically we still have 10 more minutes after that.